Chapter 16, question 6, asks you to draw the condensed structural formula for each of the following amino acids at a pH above 12. Remember, the pH scale goes from 0 to 14, where 7 is neutral, and anything below that is acidic, anything above that is basic. So pH above 12 is really, really high. You're getting to the upper limit there, and that pH is going to be above the PI. It's going to be above the PI of these amino acids. And if you want a discussion of what the PI means and how you can identify it and the effect of it and everything, I recommend the video for exercise 3 from this chapter, chapter 16, exercise 3. So, in this one, we get to draw each of these molecules. Let's draw them all as listed in table 16.2. That's at the PI. And then we'll adjust them at the end to take into account the fact that the pH is so high and that we're above the PI. So first, glutamine. Now actually, if you notice on this table, all of these have the same sort of backbone. And these blue, in all these different amino acids, the blue highlighted area is the same exact thing in every single amino acid. So we could just write that for every single compound to start with. And then we'll fill in the part that's highlighted in yellow here, the R groups, which make the amino acids different. So first, remember you have the 3 H's, because an amine is basic, so it accepts another H+. That goes to a carbon, and then you have C, and they put COO-, and that's an abbreviated way of saying COO with a minus charge, because it gave away its H because it's acidic. So then this middle carbon has a hydrogen, and I've really just copied the blue area here. Okay. So that's going to be the same for all of these. So we can take that, and we can just write it for every single one. All of these amino acids will have this backbone. Okay, now we can add in the R groups. Those are the ones coming in on top. And we'll start with glutamine. In the case of glutamine, you can see it in the sort of middle right there. It's a polar amino acid with a neutral R group, CH2, CH2, and then an amide. So CH2, CH2, and then carbon double bonded to oxygen, single bonded to NH2, amide. And that's glutamine at its PI. MET, that's one of the 3-letter abbreviations. That's the abbreviation for methionine, which is on this table here. So that's a nonpolar and hydrophobic amino acid. So the R group is CH2, CH2, S, CH3. CH2, CH2, S, and just for room, I'll go to the right here, CH3. Next, I. I stands for isoleucine, which is at the top right here. You can see the I there. And that is a nonpolar hydrophobic amino acid. And here we have a CH with a CH2 and CH3 above, and a CH3 to the left. So a CH with a CH2, CH3 above, and a CH3 to the left. Last but not least, asparagine. Asparagine is it's sort of in the middle right here. It's a polar, and so hydrophilic amino acid with a neutral R group, CH2 followed by that amide or amide. So you have the CH2 followed by the carbon double bonded to oxygen, single bonded to an amine. And that's an amide functional group. And that is asparagine. Great. So these are our amino acids, but these are the amino acids directly from the table at the pi. Here we are above the pi. And so, remember our conclusion, the conclusion we came to in question 3. We made this little table, and we saw that above the pi, the overall charge is negative. The overall charge is negative, because if you're above the pi, then the solution is really basic. And a base accepts H pluses. So a basic solution will try to steal an H plus, and that's why the nitrogen only has 2 H's there, and the overall charge is a -1. So what we're going to do is, in each of these, we're going to take an H away, and we're going to take the charge away. Notice the H goes away, so you only have the 2 left, and the charge goes away, so that it's neutral. So in each of these, above the pi, you take the positive charge away, and you take an H away. It goes from 3 to 2. Take the positive charge away and take an H away. It goes from 3 to 2. Take the positive charge away and take the 3 away. It goes from 3 to 2. Take the positive charge away and take the 3 away. It goes from 3 to 2. And so now, we have what each of these amino acids would look like. We have that NH2 on the left, which is what you get above the pi. You have what each of these amino acids would look like at a pH of 12, which would be above the pi.